Hello, my name is Lino. So I will give you my presentation. I'll try to be quick because we don't have a lot of time. Line of command, this is my field. And so my motto is also that there's no other way. It's because it's more efficient. If you work with big data, then finally you will learn how to do it. So what about the basics? There's 4 or 5 main commands that make the world work. And I'm not joking, that's how it really is. So to begin with, let's take the 3 commands, cat, gre and sed. Cat is used to see content of a file, gre to use regex of content of a file, and sed to substitute patterns in the content of a file. So let me show you an example as well. We have the cat example here. We have this file. This is Vichero text. So let's compare command cycles. If we use cat plus sed here, we have the text here. You can see the line breaks, and you can see how it differs from the first one. So you can see it's much more legible. And let's take this one, the second one, to use it further. The second important thing is the essentials. Their use is easy, but there are commands that have a lot of different options. Here we have curl, widget and xargs. Curl is for navigating and accessing URL, widget to navigate and access URL, and xargs is like a Swiss Army knife, so it's used for different things, but careful because it can also be catastrophic. So here we can see an example of a widget. It's robots.text and booking.com, and you can see at the top and at the bottom, you can see what happens at the bottom. And booking.com has all of the sitemaps here. So we need to change the command lines a bit, and if we use widget plus grep, the grep helps to filter, and we have the sitemap on the left here configured, and if we can see what we had before, and now with the use of a sitemap. So only the sitemap URLs. But we need to get rid of the red ones to make sure that we can see what we actually need. So we would substitute sitemap and colon with nothing, and that's what we get. If we make the first sitemaps of these, we'll get more sitemaps. And here we can see how they look. Let's take the first sitemaps, and here we have HTML URLs, so the ones that we are looking for, and we need URLs for each of the sitemaps. So let's do a quick code. We add xargs and while, and we will use this code. We will filter by sitemap. We replace the sitemap by nothing, and for each of the lines we use those square brackets, and in all of the lines that we have sitemap, we will use grep EO So what will be the result of all of that? We'll have 177 million URLs in the booking sitemaps. That would take out 12 gigabytes of text of URLs. And on Google we would have all the space taken. This is way too much. We cannot have all of these URLs there. If you have a solution for reducing the volume, please share it with me as well. But this is something that where you can use 4 commands, which are much easier. Sometimes we use this kind of commands and we feel that, well, there's no other option. But actually there are just 4 very simple commands you can use. And they're very simple indeed. But if you don't understand how it all works, then it's not possible to do it. So you need to learn some new things. Indeed, I insist that they're very easy as soon as you learn them. Those commands, you can use them to charge sitemaps. Let's see a few other usage cases. The line of commands, number 3, we need data sources. Here we have data source where we have a number of search items. Like white t-shirts, iPhone 13, jeans, and then we have the content of this file. So we have all of these keywords and the volume of searches gives us those URLs. This is a tool and it's an open URL. So we have keywords, percentages here, like 0.33, 0.16. We can see that iPhone searches are changing and increasing actually. And you can see the search volumes here. And we can extract this data, these keywords. And all of these are related. We can see how to do it one by one. For each of these keywords, what we need to do is use this command. Keywords, initial keywords. We will do it for each of the lines, and we'll have all the searches related to each other and all the search results. So all these keywords there, this is one way of using this URL for this tool. So the URL that I've put here that you can use it to check what it looks like, what the data looks like there. And those URLs were used until 2020. So it's a bit outdated, but some of those keywords are still very up to date. So we just take the related ones. So we take this command, use some initial keywords, we extract each of them according to the search volume. I do it in a more difficult way actually. And I end up with a table like that. So I have the keywords, the search volume, and related keywords. Of course, everyone has their own ways of working with the list of URLs with keywords. But I like to do it like this, combine them based on the search volumes. So if we take this URL, we can take out data from one URL or from one domain, and I've just formatted this example a bit for it to be easier to see. So you can see that search volume of the URL that we're using. We can also see the visibility index, the types of keyword results, the same as you had here in the link, in the URL. So those full URLs and keywords. This is another case of Majestic. You can check it with the QR code as well, but basically you can take the data from Majestic for URL analysis. And this is the graph of backlinks for OpenAI that was already mentioned several times today. So this is search changes from when ChatGPT came out, and I think this is a very useful way of working. I like to put them all together in one document, like these API data all together in one place. If we have all of this, we can do something with it all. So for each of these keywords, for each of the files, I would use the XARG, and I would deduct 100 petitions. And if you look at this example, this code here that's generated, it's the same URL from the API that you can see at the bottom, the one related link to Amazon. And you should look at this URL in your browser a bit to look what it includes. And it will give me all the related Amazon links for this specific keyword. So initial keywords, in parallel I will use XARGs, and at the same time Amazon links. I do it for each of the keywords, and then I look at the search volume. And in the end, we have the results that you can see on the left. So this is a kind of process to use for keyword search. I have put all of this data in a Google Docs document. And next week I'll also add some other examples. So don't worry, you'll have all access to all of this as well on Google Sheets. But of course, Google Sheets has some limitations as well, so take that into account. But then we also have Linux commands that you can execute from the terminal itself. And the fourth case study is the use of YGDLP to create a search engine of content inside a list of videos. So here I have used this link where I've done a Google search. I have just searched the video on Google. I've used this reproduction list. So we get the list of videos. I put some arrows there. And these are some video links. So all these video links are listed there. I'll take the first one, for instance. and then I get the list of subtitles using this command that you can see here, list subs. And here you can see different subtitles which are available for this video. You can see Spanish here, which is the one that we are interested in. So let's take this, download the subtitles, and we can see this here. So we want to start looking at this paragraph here. And this is one of the things we need to keep using further. If we want to have a transcription of the whole video, we need to look at the playlist, and we need to use a command that has been used at the top of the page. And for these 100 threads, we have 9,200 transcriptions in 5 minutes. But the simple one gave us 9,000 transcriptions in 125 minutes. So you just download that. So you can see what the difference was in the amount of time that it took. In the first case, we can see that 100 threads are used in parallel, and on the right we can see the simple options. The subtitles are being added to any playlist. So if we have all the files for all the videos in one place, it's important to distribute them by sentence, by line as well. So what we do is we substitute text with a capital letter, and that helps us to understand where the next paragraph or sentence begins. So we can do it either by paragraph or by sentence. So the flow of processes. If we have first the URLs of videos, we extract the text and the time codes. Then we do embeddings of the text, and we save them all in BBDD. We also need to use semantic searches in some cases. And here we can see a bit of Google magic. It's possible to add a bit of Python script here. So here I have a bit of a Python script which is used by the web in order to extract those embeddings. And when I consult my database, I can see the different embeddings depending on the video search. And here in the bottom you can see the long yellow result. And it only took me 0.018 seconds, which is also important that it happens very quickly. So I would create a table about all this data that we have been talking about, all these fields that were in the embedding, and we take it into account for each phrase, for each paragraph. And then we need to add the logic. So the user would make a search, then there has to be embedding of this search. And then you would use a search of the most similar results, and that's another question, how to look for the most similar sentences. There are lots of different combinations that you can use. If you have 10,000 sentences, for instance, you need to make 10,000 comparisons. So that's also something that takes time. So you look for the most similar sentences, and you extract them when they begin, and when the video begins, you take the URL and link back in the right place at the right time. So you would render this script And here we have the results. In the first line, we have the URL link, the search itself, and now how to search the word in the script. We would look for it here. When it appears at the beginning, we can look for it in other parts, and then we know that this is what it's talking about if we carry out this search. And there we go.